Hello students, welcome to online maths classroom. Today we are going to start with sequences and series miscellaneous exercise. In this video we will solve question number 1 to question number 11. So let us start with it. So these are your 11 questions which are we going to solve of your miscellaneous exercise on chapter number 9. First question is show that the sum of m plus nth and m minus nth terms of an AP is equal to twice the mth term. Okay. So this kind of questions you have done in your class 10th also. So let us start how to solve it. So firstly we need to find what are your m plus nth, m minus nth and mth terms. Okay. So what is the nth term of AP? An is equal to a plus n minus 1 d. Okay. An is your nth term, a is first term, n is number of terms and d is common difference. Now what is m plus nth term? Okay. Here at the place of n I'll put m plus n. So this will go as a m plus n is equal to a plus m plus n minus 1 d. Okay. Similarly, what will be m minus nth term? I have to replace this n by m minus n. So I'll get a m minus n as a plus m minus n minus 1 d. Okay. For mth term, you know the formula will be a plus m minus 1 d. Now I'll add this number 2 and number 3 because I need the sum of m plus nth and m minus nth term. Okay. So both the sums added together, these two terms, when I'll add the terms, I'll get 2 times a, okay, plus all these d's taken together, m plus n minus 1 plus m minus n minus 1d. Okay. So it will be, after cancellation, it will be 2m minus 2d. Okay. Okay. 2m minus 2d. So 2 can be taken common. So it is 2 times m minus 1d. Now this 2 can be taken common out of this whole term. So 2 times it is a plus m minus 1d, which is your mth term. So it is 2 times am. Okay. So we prove that sum of m plus nth and m minus nth term is equal to twice the mth term. Question number 2 is, if the sum of 3 numbers in AP is 24 and the product is 440, find the numbers. Now you know how to take the 3 numbers in AP with first term as a and common difference as d. Okay. They, instead of taking like a plus d, a plus 2d, it's better to take it as a minus d, a and a plus d. So the sum is equal to 24. This way we'll get a as 8. Okay. Also it is given that the product of 3 numbers is 440. So the product is a minus d into a plus d is equal to 440. So a minus d into a plus d into a is 440. So I get a square minus d square times a. Okay, a plus b into a minus b. This is equal to 440 and I'll put the value of a is equal to 8 so that the calculation becomes simpler. So it will be 8 square minus d square times 8 is equal to 440. That is 8 square minus d square equal to, I can divide by this 8 here. So this becomes 55. So 64 minus d square equal to 55. And after solving this, I get d square is equal to 9, which gives me d as plus minus 3. Okay. Now when d is 3 and a is 8, I will get a minus d as 5, a as 8 and a plus d as 11. So the numbers are 5, 8 and 11. And when d is minus 3, a is 8, I'll get a minus d as 11, a as 8 and d, a plus d as 5. So the numbers will be 11, 8 and 5. Okay. So the numbers are 5, 8, 11 or 11, 8, 5 depending upon my first term is 8 and the common difference is 3 or minus 3. Question number 3 is, let the sum of n, 2n, 3n terms of AP is denoted by S1, S2 and S3. Show that S3 is 3 times S2 minus S1. So I think this is again a very simple question. You know, sum to n terms of AP is given by n by 2, 2a plus n minus 1 d. Okay. And S1 is your sum of n terms. Okay. So this means this n by 2, 2a plus n minus 1 d is equal to S1. Okay. This is your first equation. Sum of 2n terms. 2n terms is 2n by 2, 2a plus. I will replace this n by 2n. 2n minus 1d. This is S2. Similarly, for 3n terms, it is S3, that is 3n by 2, 2a plus 3n minus 1d equal to S3. Okay, now what I will do is I have to show that 3 times S2 minus S1 equal to S3. So I'll consider 3 times S2 minus S1. So this is your S2, this is your S1. Okay, so 3 times this is your S2 minus S1. Okay, now what we have done is we can solve in any way, whatever we feel is good. Okay, so here what I have done is I have taken n by 2 common. So n by 2 common from this term and this term. So inside I get it here 2 times this complete minus this complete. Okay, so it becomes 3n by 2, it is becomes 4a, okay, plus 4n minus 2d minus 2a minus n minus 1 times d. Okay, so it is 4a plus 4nd minus 2d minus 2a minus nd plus d. Okay, so 3n by 2 is there outside. Okay, so when I'll arrange it, what I will be getting here is this 4a minus 2a will give me 2a, this will give me as 3nd, and this is as minus d. So this is I was getting from my previous step 3n by 2, 2a plus 3nd minus d. So from both these terms I'll take d common. So it becomes 3n by 2, 2a plus 3n minus 1 d. Okay, so this is again from equation number 3, which is my S3. So I proved that S3 is 3 times your S2 minus S1. Question number 4 is find the sum of all numbers between 200 and 400 which are divisible by 7. Okay, so you know the numbers between 200 and 400 are like 201, 202 up to 399. Okay, but the number should be divisible by 7. Okay, so let me see, I will just execute it in my mind. Okay, that which number is exactly divisible by 7. Okay, so it will come to my notice that 201, 202 they are not divisible, but 203 is divisible. Okay, so my first number is going to be 203. Okay, and also my last number 399, this is also divisible by 7. Okay, so my number will start with this, my series or AP will start from 203 and end with 399. So all these are multiple of 7, that's why they are divisible by 7. Okay, now it is an AP with first term as 203, last term as 399 and common difference as 7. Now what is AN? AN is your A plus N minus 1 D. Okay, so the last term is 399. Okay, and this is my first term, n minus 1 times 7, and after solving it I'll be getting n as 29. Okay, and this I can put in your to get the sum of n terms. The smarter and briefer formula was n by 2 a plus an or a plus l, where the last term is given. Since I know my last term, so it is better to use this one instead of using that other option. So it becomes 29 by 2. This is my first term, this is my last term, and this gives me 8729. Number 5 is find the sum of integers from 1 to 100 that are divisible by 2 or 5. Now this kind of questions are can be executed in many ways. Okay, but let us elaborate this question to understand that how this question can be done. Okay, now see, sum of integers from 1 to 100 divisible by 2. Okay, 2 or 5 means sum of integers divisible by 2 also, plus sum of integers divisible by 5 also, minus sum of integers divisible by 2 and 5. 2 and 5, that is divisible by 10. Okay, because sum of integers divisible by 2 plus sum of integers divisible by 5 will carry both. Okay, so I have to take out from them sum of integers which are divisible by 2 and 5 both. Okay, so let us execute this question in this way. Okay, so sum of numbers from 1 to 100 divisible by 2 is your 2, 4, 6, 8 like this, 100. Okay, so this is again an AP with first term as 2 and common difference as 2. Okay, last term is 100, and also it is obvious that from 1 to 100 there are 50 even and 50 odd numbers. Okay, so divisible by 2 means even numbers, that means I'll be getting n as your 50. Okay, so sum is n by 2 a plus l. I can use this as 2 plus 100 and 50 by 2. So it is 2550. numbers are there which from 1 to 100 which are divisible by 2. Now finding the sum of numbers from 1 to 100 divisible by 5. Now integers between 1 to 100 is divisible by 5 are like 5, 10, 15, so on, so up to 100. Okay, so first term it is again an AP with first term as 5, common difference as 5, and the last term as 100. Okay, so exactly I can just count also, but it is better that I use the formula an is equal to a plus n minus 1d to find out how many numbers are there. Okay, now as in the previous it was simpler to execute that between 1 and 100 there are 50 even and 50 odd numbers, but here you can use this formula an is equal to a plus n minus 1d. Okay, with an is 100, a plus n minus 1d, and you will get n as 20. Okay, so now for the sum I'll apply the formula n by 2 e plus l as the first and last term is there. So it will be 20 by 2, 5 plus 100, that is 1050. So numbers divisible by 5 will be 1050. Now which is divisible by 2 and 5 both? Because these are those numbers which are also included in the sum of numbers divisible by 2, also in sum of numbers divisible by 5. Okay, so I have to take out both of them. So you know which will be divisible by 2 and 5 both, that means divisible by 10. Okay, because 2 5s are 10. So they are numbers like 10, 20, 30, so on, so up to 100. It's again an AP with a A10, okay, D10, and last term is 100. So I can just execute as I know how many numbers are there. They are just 10 numbers. So Sn using the same formula n by 2 a plus l, this S10 comes out to be 550. Okay, so you know what we need to do now is, because 2 or 5, either by 2 or 5, okay, not by 2 and 5. Okay, so I have to apply the formula sum of integers divisible by 2 plus integers divisible by 5 minus sum of integers divisible by both 2 and 5. So it was 2550 plus 1050 minus 550, which is 3050. Question number 6. Find the sum of all two-digit numbers which when divided by 4 yield 1 as remainder. Okay, so let us start it. Two-digit numbers are from 10 to 99. Okay, now let us see, find out first which numbers will be divisible by 4. Okay, so see, 10 is not divisible, 11 is not divisible, 12 is divisible by 4. And you know, after every gap of 4, now the next number will be 16, the next number will be 20. Okay, it will be like this. But I don't have to take those numbers which are divisible by 4. Say 12 is divisible by 4, but I have to take that when I will divide, say when I will divide 13 by 4, I will get 1 as remainder. Okay, so 12 plus 1. Okay, I have to take the one next number from the number which is getting divisible by 4. So the AP will be like 13, 16 is divisible, so 17, 21, 25, and the last one is 97. Okay, so this is an AP with A13, D as 4, and the last term as 97. Okay, so applying this formula to get out how many numbers are there. Okay, an is equal to a plus n minus 1d. I get your n as 22. Okay, so the formula for again as the first and last term are given. So what is the formula for S22 is 22 by 2, that is first term and the last term. So 13 plus 97, which is your 1210. Question number 7 is, if f is a function satisfying f of x plus y is equal to f of x into f of y for all xy belonging to n, n means natural numbers, such that f of 1 is 3 and summation x varies from 1 to n, f of x is equal to 120, find the value of n. Okay, so firstly I just need to frame out that what kind of numbers are there. Okay, f1 is equal to 3, f1 is equal to 3. So this is my first term of whatever series I am getting, because here we are talking about the summation sign. So you know that the sum when taken for the terms, that it will convert the sequence to a series. Okay, so let us see for xy values. Okay, f of x plus y, xy both are natural numbers, so I have to start with your 1. Okay, so see from here, xy, this is fx, this is f of y, and this is your f of x plus y, which can be calculated as is equal to f of x into f of y. So when both x and y are 1, f of 1 is 3, f of 1 is here again 3. So it will be like f of 1 plus 1, which can be calculated by this formula as f of 1 into f of 1, that is 3 into 3, that is 9. Okay, when x is 1, y is 2, this is 3, f2 I calculated, it is 9 from here. Okay, now f3 can be written as f of 1 plus 2, which is by this formula f of 1 into f of 2. That is f of 1 is your 3, f of 2 is your 9, so that is 27. Similarly, when I take both 2, okay, so f2 is 9 from here, okay, and again f2 is 9. So f2 plus 2 will be like f2 into f of 2. So this is 9 into 9, that is 81. So this way I'll be getting the terms. Okay, so f1 is like 3, f2 is your, say it is 3 square, f3 is your 3 cube, and f4 is your 3 4. Okay, that way. Now similarly f5, f6, they will be of this kind. So our series will be like your 3 3 square, 3 cube, 3 4 up to n terms. Okay, so this is a GP. This is a GP with first term as 3 and common ratio as 3. Okay. So sum of GP, it is given as your 120. Okay, so what is the formula for sum? Okay, as r is greater than 1, so I apply the formula of sum as a r raised to power n minus 1 divided by r minus 1. Okay, so I'll apply this formula. A is 3, r is 3, sum is 120. Okay, from here see how the calculation is done. This is divided by 2, take it to other side, this becomes your, and also divide by this 3. So it will be your 40 into 2, that is 80. So 3 raised to power n minus 1 is equal to 80. Okay, so 3 raised to power n is equal to 80 plus this minus 1 taken to other side, 81. Okay, so 3 raised to power n is equal to 81. That is 3 raised to power n is equal to, your 81 is 3 raised to power 4. So by using the properties of exponents, n is turning out to be 4. Question number 8. The sum of some terms of GP is 315, whose first term and the common ratio are 5 and 2 respectively. Find the last term and the number of terms. Okay, so let A is the first term of GP and R is the common ratio. Okay, so A is 5, R is 2. As R is greater than 1, so you know which formula I'll be applying for Sn. It will be A times R raised to power n minus 1 divided by R minus 1. Okay, now sum of some terms. So there are n terms. So here Sn is your 350. So let us apply this formula. Sn is equal to A raised to power A into R raised to power n minus 1 divided by R minus 1. Okay, so this is your 315 is equal to A times R raised to power n minus 1 divided by R minus 1. R is 2, A is 5. You put all these values. Okay, so it is simply because the denominator is just simple. So you'll get it as this. So divide by this 5 here. 2 raised to power n minus 1. That is 2 raised to power n minus 1 equal to 63. Take it to other side, it will be 64. Okay. So you know 2 raised to power n is equal to 64 means it is 2 raised to power 6. So I'll get n as 6. So how many terms are there? 6 terms are there. Okay. Now what we need to do is we will find the last term. So last term is your nth term, which can be found by using the formula AR raised to power n minus 1. So A is 5, R is 2 and n is 6. So by using this formula, okay, you can just use it as L also, AN also. Okay, so you get this sum as 5 times 2 raised to power 5, which is your 5 into 32, that is 160. So the last term is 160. Number 9 is the first term of GP is 1. The sum of third term and fifth term is 90. Find the common ratio of GP. So the sum of third and fifth term means A3 plus A5 is 90. Nth term, the formula is for GP AR is to power n minus 1. Please don't mix the formulas of EP and GP. Okay. So n is your 3. I'll get A3 as AR square. Okay. So A is your 1. First term is 1. So I'll just get it as R square. Similarly, A5 is your AR raised to power 4. But A is 1. So it will be R raised to power 4. Okay. Now put it here. I'll get R square plus R raised to power 4 is 90. Okay. So this becomes an equation r is to power 4 plus r square minus 90 equal to 0. So this is a biquadratic equation, but we are familiar that how we can solve it. Put r square is equal to say x. So it will become a quadratic equation. So like it becomes x square plus x minus 90 equal to 0. Now the factors will be for 90, 10 and 9. So this is as the sign is plus 10x minus 9x minus 90 equal to 0. So after factorization, I'll get it as x minus 9 into x plus 10 equal to 0. That is x is equal to 9 or minus 10. Okay, 9 or minus 10. But since x was your r square, so no square will be equal to negative number. So this is not possible. Okay, so we will reject this case. X is 9. That means r square is 9. So r will be your plus minus root 9, that is plus minus 3. So what is the common ratio? It is either minus 3 or 3. Question number 10. The sum of three numbers in GP is 56. This is a very, very important question. If we subtract 1, 7, 21 from these numbers, in that order, we obtain an arithmetic progression, that is AP. Find the numbers. Okay. So these kind of questions are very important because these are the combined problems of AP and GP. Okay. Numbers were behaving in GP, but after some say addition, deletion or subtraction, addition, they convert to AP or AP convert to GP. So these kind of questions are very, very important. So what were the numbers we are going to take? That is three numbers. We'll take it as A, AR, AR square as the number are in GP. A is the first term, R is the common ratio. Now the sum is 56, that is A plus AR square is 56. Okay. So AR square equal to 56 minus A minus AR. That is your equation number 1. Okay. You can just retain it like this also. You will take A common, so it will be 1 plus R square equal to 56. Okay. A times 1 plus R square equal to 56. That way also it is okay. Now when we use subtract 1, 7 and 21 from these numbers, the numbers, so what will happen? It will become A minus 1. Okay. This will become AR minus 7. This will become AR square minus 21. Now these numbers will form an AP. And you know what is there in an AP? The common difference means this B minus A will be equal to C minus B. Okay. Common difference is same. So from here AR minus 7 minus A minus 1, this is equal to this your AR square minus 21 minus AR minus 7. After solving it, opening it, I'll get an equation AR square minus 2AR plus A minus 8 equal to 0. Okay. Now I just need to put this value of AR square. Okay. So here I conclude that instead of keeping it like this, it is better to get the value of AR square so that I can directly put it here. Okay. So 56 minus A minus AR minus 2AR plus A minus 8 equal to 0. Okay. So after solving, I'll get it as minus 3R is equal to minus 48. That is AR is equal to 16 and A is equal to 16 divided by R. Okay. So it is very simple. Now put this A as 16 by R in that equation, which was your equation number 1. A plus AR square equal to 56. Why? Because we need this R. Until we get this R, we will not be able to find the terms. Okay. So you put A as 16 by R here. Okay. And just cross multiply. So it becomes 16 times 1 plus R square equal to 56R. Okay. So bringing the terms to one side, 16 plus 16R plus 16R square minus 56R equal to 0. Okay. You can take 8 common. So it becomes 8 times 2R square minus 5R plus 2 equal to 0. Now either you can do it like this as divide to other side, or as you know product of two things is 0, then either one can be 0. So 8 is never equal to 0. So this is required to be 0. So 2R square minus 5R plus 2 equal to 0. Again the factorization, which will be your 2 to the 4. I need 4. So it will be minus 4R minus R. Okay. So I'll get the factors from here. 2R minus 1 equal to 0 and R minus 2 equal to 0. That is R is either half or 2. So when R is half, your A is 16 by R. That is, it becomes 32. And when R is 2, your first term becomes 16 by 2. That is 8. Okay. Now when R is half and A is 32, let us find out the numbers. They were A, AR and AR square. So they will come out as 32. This is half into 32 is 16 and 32 into half is 8. Similarly, when R is 2, A is 8, they will turn out as 8, 16 and 32. Okay. So if your R is half, then they will be in reverse order like 32, 16 and 8. And if R is 2, they will be like 8, 16 and 32. Question number 11. Number 11 is a GP consists of an even number of terms. Okay. If the sum of all the terms is 5 times the sum of terms occupying odd places, then find its common ratio. Okay. So let us see this question. Okay. And we will just take one line and then try to frame out the solution. A GP consists of an even number of terms. Okay. GP consists of even number of terms. So if there are say n terms, okay, we know the formula of Sn is your a times r is to power n minus 1 upon r minus 1 if r is greater than 1. Okay. And since the GP is having even number of terms, so instead of taking n, I will take it as 2 times n. Okay. So that it always remains even. Okay. So the terms of GP like for first term a and common ratio are as a, ar square, so on, so up to how many terms? 2n terms. Okay. So instead of n terms, they are 2n terms so that I ensure that they are even. Okay. Now finding sum of all terms and sum of terms occupying odd places. Sum of all terms. Okay. And then I have to find, then I will establish this relation. But firstly, I'll find sum of all terms and then sum of terms occupying odd places. So see, this is the sum of all terms. Even terms a, ar square, so on, so up to 2n terms. So applying this formula, Sn is equal to this. See, this is Sn, I have to find S2n. So what will change? Your r raised to power will become r raised to power 2n minus 1 upon r minus 1. Okay. Now sum of terms, this is sum of all terms. Now sum of terms occupying odd places. Now see, this is the first place which is odd. So this number will come. Second is your even. Third is odd place. First place, third place, fifth place, like this. So the second is AR square. Next is AR4 up to. Now see, there are 2n terms. So how many are odd? N are odd and n are even. So I will get this as terms AR square, AR is to power 4 up to n terms. First term is A. Common ratio is your AR square upon A, that is R square. Okay, so let us denote this sum as S1. So we will take this S1 as A times, as your first term is just A. What is your R? R is R square. So it will be R square. See, in place of R, I have to put R square raised to power n minus 1 divided by R square minus 1. So it becomes R raised to power 2n minus 1 upon R square minus 1. So this is my equation number 1. Sum of all terms, and this is the sum of terms occupying odd places. Okay. Now the relation is that this sum is 5 times this. Okay. And I have to find this R, that under what condition this R is having what value. Okay. So it is given, this is my sum of all terms. Equation number 1 is equal to 5 times this is sum of terms occupying odd places. Okay. So see from here that how we are going to solve it. Now you know a square minus b square equal to a minus b into a plus b. So it is a times r raised to power 2n minus 1 divided by r minus 1 is equal to 5 times. So this is, I will just break it, r minus 1 into r plus 1. Okay. So it becomes, say you bring this r minus 1 to the other side, or if you know, you can just directly cancel it from here. Okay. Also, you see that they are also getting cancelled. Okay, they are also getting cancelled. This a is also getting cancelled. Okay, so what will I get? You cancel it in any way. I'll just get it as to this side, because this will be cancelled. This a will be cancelled. R minus 1 will be cancelled. So to this side I'll get just 1, and to this side I'll get 5 and divided by r plus 1. Okay, so after cross multiplying, I'll get r plus 1 is as 5. So r is equal to 4. Hence, the common ratio is 4. So I hope that question number 1 to question number 11 are clear to you. Practice it well. Okay, do neatly on your book. Practice it twice, thrice. Okay, it will clarify your many concepts. Thank you.